Good afternoon, everyone. In the last some lectures related to TYBC analytical chemistry belonging to ultraviolet visible spectroscopy, we have learned some topics related to ultraviolet visible spectroscopy. In the similar pattern, now this is a part 5, and in this topic, in this video, we are going to study the statement of Beer's law and its expression. Again, the combined Lambert's-Beer's law and its expression. Now here, if we see the Beer's law, now the Beer's law is related to concentration. Lambert's law is related to thickness of the medium. Now the statement, according to statement, when a beam of monochromatic light is allowed to pass through a transparent medium, then the rate of decrease of radiant power with respect to concentration of the medium is directly proportional to intensity of transmitted light. Now, another statement for the Beer's law that can be stated, if we see the statement is given on this page. The absorbance of the solution is directly proportional to concentration of the solution, provided that path length remains constant. Now here, path length, that means thickness, remains constant. Accordingly, that equation, that statement can be expressed in equation or expression form. Negative, that is negative sign indicates that is a decrease in thickness, or sorry, decrease in concentration with respect to light. Negative, or we can say minus di by dc is directly proportional to I. Therefore, minus di by dc is equal to ki, where k is proportionality constant. Therefore, minus di upon I, rearranging these equations in the proper form with respect to similar terms. Therefore, minus di by I is equal to k into dc. The dc is divided, that can be multiplied at the right hand side to k, that is proportionality constant. Now this third equation, minus di by I is equal to k into dc, that is a rearrangement form of the equation of Beer's law. Now integrate this equation between proper limits. If we integrate this equation between the proper limits, so that integration have the limits, upper limit is I0 and lower limit of IT at left hand side, while at the right hand side the lower limit is 0 and higher limit or upper limit is C of concentration, belonging to concentration. Now if you see, the integrated form of this equation is minus sign here, and here also we have taken as it is, in bracket ln I IT upon I0. The upper limit is I0 IT and a lower limit is I, where I0 is nothing but the intensity of incident light and IT is the intensity of transmitted light, is equal to k into concentration of C. The integrated form of this equation is in bracket C. So here C is the upper limit, which is taken as it is from the last line, and 0 is the lower limit. So here, if we integrate applying lower and upper limit, here we get the equation minus ln IT upper limit I, where IT is added first, minus lower limit I0 is added, that is ln I0, is equal to k into C. Upper limit is added first, and then lower limit 0 is added, minus 0. So k into 0, that is a 0. So directly 0 is added here, or can say we have written already. So ln IT, this negative sign is shifted to the right hand side. So Kc positive here, and this is the Kc becomes negative because this negative sign is shifted to right hand side. Now the equation, this equation can be written as ln it minus ln I0, that can be written as ln it upon I0, because ln A minus ln B, if this equation is there, if this natural log form is there, then we can write in the divisional form ln A upon B. Similarly, ln it upon ln minus ln I0, that can be written as ln it upon I0 is equal to minus Kc as it is. This term is taken as it is. So it upon I0 is equal to e raised to minus Kc. If we remove the ln, then we can write here e, that is exponential form, because natural log is cancelled, and we apply exponential form at right hand side. So it upon I0 is equal to e raised to minus Kc. So this is the exponential form. So it is equal to, here I0 is divided by here, divided to it, that can be multiplied at right hand side to e raised to minus Kc. So or here this equation can be written in OR form, it is equal to I0 e raised to minus Kc, it is equal to I0 10 raised to minus Kc. So this is the exponential form, this is the logarithmic form. This is the logarithmic form. So this is, we can say, with this content I conclude this lecture. In this lecture we have learned what is the statement of Bayer's law and what is equation of or expression of Bayer's law. In the next lecture, the remaining part of this video we will continue in next video, that is combined Lambert's Bayer's law. With this content I conclude this lecture. Thank you for patience listening. I will again kindly request to all my viewers to subscribe my channel. This is the academic channel, especially it is useful for SY, BSc and TY basic chemistry student, those who have taken analytical chemistry. Thank you very much.